Welcome to iLectureOnline, and here these videos are going to be about chemistry. So here's our very first one on chemistry, and of course we start with the beginning, the introduction. And we're going to start with some basic terms. It helps to understand what those basic terms mean before we move on to the next stuff. So first thing is, what is matter? And the definition of matter is that anything that takes up mass, takes up space, and that has mass. So usually when we talk about matter, it means it's made up of atoms. Now, what is mass? Well, mass is a word that we use as a measure of how much matter we have. So how many atoms do we have? How many protons do we have? How many particles? So it's a measure of the quantity of matter. That's what mass is. And it's independent of its location. For example, if I have a kilogram of matter and I go up to space where things are weightless, it still has the same mass, regardless of being on Earth or in space. Now, we tend to use gravity as a form to measure the mass, but nevertheless, there's a big difference between them. So weight is a measure of how much influence gravity has on that matter. So when I have a kilogram of matter on the Earth, gravity pulls down the matter, and therefore it has weight. Now we go with that matter up in space, still have the same matter, same mass, but it will have zero weight if it's weightless. So it's really a measure of the force of gravity acting on the matter. A substance is a form of matter that has what we call a definitive or a constant composition. In other words, if you have some stuff there and it all looks the same, you take any part of that stuff and it looks exactly the same no matter where you got it from, that would then be what we call a substance. And some examples of that are water, so it doesn't matter which drop out of a bucket you get, they all look the same. Table salt, it looks the same continuously everywhere. Silver, oxygen. So it's a basic principle or a simple form of substance, and so we call that matter. We call it substance. So a mixture is a combination of two or more substances. So we combine things together, we now have a mixture. So we have water and table salt, you put it together, you now have a mixture. Now it turns out, if you put table salt in water, not too much of it, it tends to dissolve. And then again, everything will look exactly the same. Now, of course, you taste it and you taste the salt in it, so it's not exactly the same as pure water, but it's still a mixture, and in this case is what we call a homogeneous mixture, which means even though it has two or more substances in it, it has the same properties, the same look, the same feel, the same taste everywhere throughout the mixture. So that's called homogeneous. Heterogeneous is that it has two or more substances mixed together, but in this case you can actually see that there's differences there. There's different things in there, and usually if you take some of the heterogeneous substance from one portion of it and then you take some of the other portion, you probably don't have the same proportion of all the substances that are in there. For example, if we mix sugar and sand, it would be very difficult to have a mixture where you can have everything in the exact same proportions, and nevertheless you can still see that there's two different substances within the mixture. So that's called a heterogeneous mixture. Then there's the word property, and so we have what we call physical properties and we have chemical properties. Physical properties is something that can be measured without changing anything about the substance or the item that you're measuring. For example, if you want to measure the mass of something, well, you take whatever you've got, you put it on the scale, you measure it, and there it is, it hasn't changed. That's called a physical property, like the mass, the weight. But a chemical property is something that you usually have to go through a chemical change. You have to do something to the mixture or the substance in such a way that it's now different because of the way you handled or observed it. It goes through what we call a chemical reaction. For example, if we want to measure the ionization energy, and we'll get into what that is. Ionization is when you either add or take away electrons. You now have a different type of substance. We now have an ionized substance, so we had to go through a chemical reaction. And so to measure how much ionization energy something has, you have to change it, and that's therefore called a chemical property, not a physical property. So those are some basic definitions, and those will come in handy. If you ever wonder what they mean, just come back over here and say, oh yes, I remember now, that's what it means. And it really does help to understand the difference between those. So that's a nice introduction to at least the terminology that we'll be encountering. Of course, in chemistry, we will encounter much more terminology, but at least this is a nice little set to start with. And